Are you having trouble with physics? Are you having trouble seeing how this applies to your life? Well, this is the video for you. Welcome back to another episode of Isabel Doesn't Know What She's Doing in Science. In this episode, we're going to go over physics, which is a thing apparently that I had to take. In Module 1, it's motion in one dimension. Now, I'm not talking about like dimension in like 2 dimensions in like that kind of, yeah. The only formulas we have are velocity and speed, but don't get them mixed up because they're not the same. Velocity is a vector and speed is a scalar. Vector means it has direction and magnitude, and scalar just kind of means it has, that. Velocity's formula is total displacement over total time, and speed is total distance over total time. But we don't get those because we're supposed to have them hidden in our heart. Yeah, I know. We also look at instantaneous velocity, which is the velocity at an object at the moment in time. Average velocity is also the velocity of an object over an extended period of time. Here we have a slope. This is a slope. It has curves. But if it goes down and then up, like here, that means that it changed direction. Some other cute stuff is acceleration. The formula for acceleration is total velocity over total time. And you see, we see acceleration all the time, like that, and also that. That would be deceleration. Now we skip over to Module 2, which is the one-dimensional motion equations and free fall. Free fall. Free fall. This one is the most confusing module I've ever had so far, but of course I've only had 4 modules. These equations include BF equals VI times A times T, BF squared equals VI squared plus 2A times total displacement, and total displacement equals VI times T plus 1/2 times A times T squared. We also learned how to find total displacement when using graphs, which happened and that did something. But I know how to do it, so it works. We also learned that acceleration, when it's being used as gravity, is actually 9.8 meters per second squared. It's always that, or it's like negative 9.8. Terminal velocity. The velocity of a falling object has when, due to air resistance, its acceleration is reduced to 0. This is the maximum velocity of a falling object subject to air resistance that can achieve. That I didn't read that well. But like, when you're like skydiving and then like you're falling, you can't fall any more than like a certain, you can't fall faster than like a certain like velocity. Module 3, my ballpark. So we're going to be looking at 2-dimensional vectors, okay? We're using a lot of graphs and a lot of numbers and letters. So stay with me. So our theta would equal the tangent, like an inverse tangent, times y over x. Y equals magnitude times the sine of theta, and x equals magnitude times the cosine of theta. It's really confusing, but it's actually really easy. X altogether equals ax plus bx plus cx. The same with y. It's going to be ay plus by plus cy. We also learned how to draw vectors, and like if we're minusing vectors, how to do that, and like for adding vectors, how to do that. Like it goes like this and then this, but if it's negative, it goes like this. So if you want to find the magnitude, it's a square root of x squared plus y squared. Module 4, motion in 2 dimensions. So we didn't really learn anything like new here. Not really anything. No, we did learn something new. Okay, so the parabolic motion of a projectile, which is, y'all know when you throw something, y'all know when you like yeet something and it makes like an arc in the air and then falls to the ground? That's what the parabolic motion is. How hard you throw it is pushing it up, but gravity is pushing it down, which creates this arc. Okay. Parabolic motion is a motion that occurs when an object moves in 2 dimensions but has 0 acceleration in one of those dimensions and a constant non-zero acceleration in the other. You can do v initial times the sine of theta over gravity. And then this one that's very, 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 did I say very, very important, is range equals v initial squared times the sine of 2 times theta over gravity, which is the same as t, but with the 2 next to the theta. So that's it for now. And we'll pick up where we left off in the next episode of Isabella's Struggling in Science.